Welcome to Praveen Patil, College of Diploma Engineering and Technology. Myself, Raj Gheware, working as a lecturer in Mechanical Department. So, today we will be looking at the subject Thermal Engineering for SEM 3rd. We have started with the 4th chapter, Steam Nozzle and Turbines. So, in this chapter, we have discussed about the definition of the nozzle continuity equation, types of the nozzles, Mach number, critical pressure and Chock flow conditions. We have seen the applications of the nozzles. We have seen the classifications. So over here in the classifications there are classifications. There are total 7 classifications of the nozzles. We have seen the impulse turbines, reaction turbines, compounding of steam, velocity compounding, pressure velocity compounding. Now we will be discussing about the regenerative feed heating. Now what is regenerative feed heating? So in this regenerative feed heating, what happens is the process of draining steam from certain sections of turbines during its expansion and using these steams for heating feed water supply to a boiler is known as bleeding, and this process of heating feed water is known as regenerative feed heating. So in simple terms, if you want to understand, when this steam is passed to the turbines, there is some leakage of this steams. So that steam, it is being passed to this bleed steam, or we can call it as a as well as to a feed water heater. So what does this do? It heats this coil. There is a coil present in this feed water heater. So what does this coil does? So this coil heats the steams. Now in this, condensed or condenser passes through the coil of a feed water heater, which is surrounded by a bleed steam from the turbines. This bleed steam heats the condenser flowing through the coil and heats it. So that heated steam is being further passed to a pump, where it is being again supplied to a boiler with the help of a feeding pump. So this is how it has been passed to this boiler. Whereas on the other part, the existed steam, exhaust steam, which is passed to a condenser. What is the condenser do? Condenser cools this. The condenser over here, in this condensers, the water is being stored over this area, that is called as a hot well. This area we call it as a hot well. So here cool water is being passed in and cool water is passed out. So there is a change in phase occurs, and this change in phase reaches to a liquid phase. So that is stored over here, hot well. So this is all about regenerative feed heating. So in this regenerative feed heating consists of two types. First one is when the bleed steam does not mix with feed water. Second one is when the bleed steam is mixed with feed water, and which has been further pumped to a boiler using a feed pump. So there are certain advantages of this feed heating. Advantages of this feed heating is: first one, the thermal efficiency of boiler increases as heat input decreases. Stress produced in the boiler is reduced. Capacity of condenser is reduced and reduces fuel consumption. The only disadvantage is the cost of the power plant increases. So now let's discuss about the simple diagrammatical arrangement of throttling governor with oil relay. So the much more easier understanding of this throttling governor is, I will share you the video. Through this we will be able to understand the throttling governing processes. So over here, throttling process is nothing but regulation of quality of water rejecting from nozzle for controlling the speed of the turbine as a load variation. So here there is a governor and impulse turbine. So through this governor, rod is been passed and there is a sleeve present which is attached to this gear arrangement, bevel gear arrangement. Now this attached to this shaft is further attached, which is being used to control the main wall, So now what happens is, whatever the steam is entering through the main wall, that passes through the buckets which is present in the impulse turbine, which rotates these buckets and which is used for the rotation of the turbine. Now this steam flowing into this impulse turbine, which passes to the blades and cause it into a rotation. Now this steam is being firstly passed to the main wall, and here there is a bevel gear arrangement which is used by the rod which is attached to the governor. Now what happens is, when this bevel gear rotates, this shaft also rotates. Now there is a sleeve present. Now this sleeve is attached to this part by a fulcrum. So this sleeve will move up and downward. So when it moves up and downwards, when it moves up, it is been pushed forward, it is been pushed downward. So when it is been pushed forward, the control flow of steam can be obtained. So if there is less flow of the supply of the steam, we can maintain a less flow of supply, or we can maintain a high flow of supply. So in order to maintain a constant rotation of the impulse turbine, so this is nothing but the throttling process. So this is all about the throttling governing processes. Now we will be discussing about the nozzle control for steam turbine. So in the name itself, the nozzle is control. The nozzle of a steam turbine is controlled. Now here we are able to see N1, N2, N3. These are the nozzles. Now the steam flowing through this nozzle is controlled by a valve. Now this valve is represented by control valve V1, V2 and V3. So what is this used for? In order to control the supply of steam through these nozzles. Okay, now in figure B and C, we are able to understand that the number of nozzle group may vary from 3 to 5 or more. Various arrangement of group of nozzles and valve can be employed. Two arrangements are shown in figure B and C. As we are able to see, the V1 is used to control the nozzle N1, like that V2, V3 is used for the controlling of the nozzle N2, N3 and N4. This is all about the nozzle control of a steam turbine. So we will be discussing about the bypass governing. So in bypass governing, modern impulse turbines operating at high pressure consist of number of stages of comparatively small mean diameter. All such turbines are designed for a definite load termed as economical load, at which efficiency is maximum. This type of governing is not applicable where the very small enthalpy drop in the first stage. Also, it is desirable to have full admission in high pressure stage at economical load so as to reduce losses. These difficulties are overcome by use of bypass governing. Now here we are able to see the steam entering to the turbine passes through the inlet valve. So this is the inlet valve. This steam will pass through this inlet valve. Now when the steam passes through this inlet valve, which is controlled by the governor, the steam after passing through the inlet valve enters nozzle box or a steam chest. So this is the nozzle box. We can also call it as a steam chest. For the load up to economical load, the governing is effected by throttling. That is by controlling the load as by a bypass valve. So this is the bypass valve which has been controlled. Bypass valve automatically allows the steam to pass from the first stage nozzle into steam belts, this steam belts. So over here, when it passes, So the control load, a bypass valve opens automatically, allowing the steams to pass from the first nozzle box into a steam belt, so the steam enters into the nozzle on the fourth stage. So over here, as the load of the turbine decreases, the bypass valve closes. So that means when the load decreases, this bypass valve will get closed. The bypass valve is also controlled by a speed governor. So we are able to control this bypass valve through by using a governor. So this is all about the bypass governing processes. Now we will be looking at the last part of this chapter, that is losses in steam turbine. So any turbine machine extract energy from high pressure steam and convert it into shaft work. The total energy content available in steam supplied to the steam turbine is not completely converted in the form of mechanical and electrical energy. So there might be some losses happening in the turbines. So let's see the losses. The first loss, we called it as a admission losses. Now what is this admission losses? The viscous force between steam particles, heat losses from steam before entering the nozzles, deflection of flow in the nozzle, boundary level developing in the nozzle. So this losses we called it as a admission losses. So let's see what is a leakage losses. So in the name itself, leakage losses, it is the losses taking place through main valve and regulating valve, seal and glands, space between nozzle and a moving blades, space between diaphragm and shaft of a turbine through which the leakage losses take place, space between moving blades, rings and turbines casing, which leads to the loss of steam, that we called it as a, that we consider it as in the leakage losses. Now let's discuss about the third type of loss, which is a frictional losses. So in the name itself, frictional losses, frictional resistance is offering during flow of steam through nozzle on moving and stationary blade. In most of the turbine, the blade wheels rotates in a space full of steam. The viscous frictions at wheel surface cause admission losses as the steam passes through the nozzle wheel. Now in this frictional losses, the energy loss also take place when steam jet turns along the curvature of the blade surface. The turning losses depends on the angle of the turning, which leads to the frictional losses. Let's discuss about the fourth losses, exhaust losses. Now in the exhaust loss, that means we can consider it at the exit where the steam is leaving. So over here, the energy content of the steam is not fully utilized in the turbine. Despite of being at very low pressure, the exhaust coming out of the turbine and entering the condenser carries some of the kinetic energy and useful enthalpy, which is directly energy losses, which we consider in the exhaust losses. Let's see what is radiation and convection losses. Now in this, when the steam turbine operates at a relatively high temperature, okay, through some of the heat energy of steam is radiated and converted from the body to turbines to its surrounding. This leads to the rise of the losses. Let's see the losses due to the moisture. The steam passing through the last stage of the turbine has high velocity and large moisture content. This moisture content, which leads to the decrease in the efficiency and which leads to the loss of due to the moisture content in the steam. So this is the last losses, which we called it as a carryover losses. Now what is this carryover losses? So when steam passes from one stage to the another through the diaphragm, some energy loss take place, which are referred to as carryover losses, and through the kinetic energy of a steam available at succeed stage or a moving blades for utilization is very less that of the exit at preceding stage. Now this is due to formation of adhesives in annual space between the nozzle and the moving blades. Due to the moisture, air life of fan blades is decreased due to erosions. So which leads to the loss of carryover losses, which we consider in a carryover losses. So these are the losses. So this is all about the losses in a steam turbine. There were total 7 losses. So we have covered the points in this 4 chapter, steam, nozzle and turbines. So we will stop over here. That's all for today. Thank you.